Up until this point, we have been talking about Punnett squares and using Punnett squares to predict the probability that offspring will inherit certain traits from their parents. There's another tool that we can use to track the inheritance of traits as well, and that's called pedigree charts. So today we're going to talk about pedigree charts and their application and how to read them. So what exactly is a pedigree chart? Well, a pedigree chart shows the record of the family of an individual, and they can be used to study hereditary conditions or traits. Punnett squares we use to study traits. Pedigree charts are usually used more to study the inheritance of genetic diseases. And they're especially useful when you're studying a large family that has several generations. Whereas Punnett squares really only covered 2 generations, the parent and the parent's offspring. Pedigree charts can cover several generations at once. So Punnett squares, they're used in the field of genetics. Scientists use them to study new diseases and to help establish the mode of inheritance, but also genetic counselors use pedigree charts to help determine the distribution of disease in an affected family. So if you're having a child and you know that there's a genetic disorder somewhere in your family line, it could be in a cousin, a grandparent, an aunt or an uncle, or maybe one of your parents. Genetic counselors can use that information and create this pedigree chart from your family tree to tell you what the odds of you passing this gene on to your children. So this is kind of like a real-world application. Okay, so let's talk about the organization of a pedigree chart. And the first thing we need to talk about is how generations are represented. Generations are represented by Roman numerals, and they're always in line with each other in the same row. So you can see Roman numeral 1, that's the first generation we're looking at, and those are parents, and those parents are next to each other. They're in line with each other. Then if you look down to the next generation, you have their children and their children's spouses. They're in line with each other, and so on and so forth. So Roman numerals represent generations. Males are represented by a square, and females are represented by circles. So in this chart we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 males and 1, 2, 3, 4, 5, 6, 7, 8, 9 females. And in a Punnett square, in a pedigree chart, this pedigree chart, we're looking at 2 generations. We've got the parents at the top, and they are connected with a horizontal line. And then below them, we've got their offspring. And there are 5 offspring, and they are connected to the parents by a vertical line, and then there's a bracket beneath the parents that has all of their children within that bracket. So all the siblings are within the same bracket. Now, you'll notice that in some of these pedigree charts that I've shown you, there have been things that have been shaded in. Some of the individuals are shaded in. And being shaded in has a meaning. Any shape that is shaded in, that means that person is affected with whatever genetic disorder you're tracking. If it's not shaded in, that means that they do not have the condition, or as this chart calls it, that they're normal. So at the top, or in this chart, we see it's a marriage, and the male and female are both not affected, and there are 5 children, and there's 2 daughters and 3 sons, and 1 son is affected by the condition. So as I stated earlier, genetic counselors use pedigree charts to predict the probability of transmitting an inherited disorder. So what we see in this chart here, again, the affected individuals are shaded in black. So if you look in generation 3, individual number 4 is a male and he has the disorder. Generation 3, individual number 6 is a female and she has the disorder. But up in generation 2, we see 2 individuals that are only half shaded in. Well, what that means is they are heterozygous for the trait or disorder. And so they have passed that gene on to their offspring, and 2 of them have the disease as a result. So when you see something that is half shaded in, that means that they're heterozygous for the condition, or as we often call it, we call it carriers. They're carriers of the disease. They don't actually have the disease, but they do have the gene. And you'll recall from Punnett squares, that would be a recessive gene. This disorder is a recessive gene. So we're going to take a look at some examples in class. We have several worksheets and problems to go through to get familiar with using pedigree charts. Okay, thank you for watching.